Hi mathematicians, this is the video for the level 3 and level 4 questions on the assessment for your retake. And I'm going to use this example of test scores. So clearly you can see that this student has been doing a really great job, right? They're pretty much getting all A's and their lowest score is almost an A. So they're doing pretty great. Well, in that case, since all of their scores are pretty close together, if we want to get an idea of about how well they're doing, the measure of center that we would want to use would be the mean. And remember the steps to find the mean. For your first step, you would add all the values together. Then you count how many numbers you have. You have 1, 2, 3, 4, 5, 6, 7. So then you take this total that you got in step 1 and you divide by the 7 values. And then when you do that, the mean is going to end up being about 94, like pretty close to 94 based on how I round. So that mean of 94 is right there, pretty much smack dab in the middle. I'm sorry for those of us that don't know what that means. That's an old person term. The mean is right there in the middle. So the mean is a good measure of center that tells you how well you're doing. On average, you usually get somewhere around a 94 on all of your test scores. Then recall from previous classes that if we want to measure our variability, and remember, variability means how spread out is your data, then in that case, we would use the standard deviation. And remember that we're not going to calculate the standard deviation by hand because it is a lot of steps. Instead, we're going to use your graphing calculator and recall that the standard deviation is measured by this one right here. So our standard deviation, our measure of spread, is going to be pretty close. That's what these little wavy equal sign marks mean. It means it's pretty close to 3.8. So in this case, because all your information is very close together on the dot plot, the best measure of center is to use the mean, and the best measure of variability or spread is to use the standard deviation. Now, let's imagine that you've been doing great, and then you have a really bad day on the day that you're taking the next test, and you get a 55 on a test. So remember the term for that 55 it's called an outlier. And it's called an outlier because it's really far away from where most of your data is. It doesn't fit in. So now to find the mean, the first thing I would do is add together everything, including that new score of 55. And I don't have 7 numbers anymore because I have 1, 2, 3, 4, 5, 6, 7, 8. So I am going to divide this time by 8. And so now that mean is actually going to be pretty close to 89. So not exactly 89, but pretty close. So if I look where my middle, where 89 would be on the dot plot, this is where my mean is, and it's not right in the center anymore. Why is it not in the center? Remember that the outlier does what we call skewing the mean. What it does is it drags that mean down so that the mean is actually not in the center anymore. So it's not going to be our best measure of center because it's not in the middle thanks to that outlier. So when you have an outlier, you don't want to use the mean as your measure of center because the mean is impacted greatly from having an outlier. Again, that outlier skews your data and doesn't make it in the middle anymore. So instead of using the mean, we have to use something else. So now I've arranged the data in order from least to greatest so that I can see where the middle is. And you can see that the middle is right here in between 90 and 94. What is that middle value called? Remember, that middle value is called the median. And what is halfway in between 90 and 94? Well, the median is going to be 92. So if I go back to my dot plot and I go up to 92, you'll see that the median is not exactly in the middle, but it's closer to the middle than the mean. So whenever you have an outlier, the measure of center that you use instead of the mean is going to be the median. Now let's talk about the measure of variability or spread. So remember before you had that low test grade, which was an outlier, that the standard deviation was 3.8. But now that we've included our outlier, you can see that the standard deviation is actually now closer to 13. So it's a lot more spread out because you've got that outlier that's all the way down here. So our goal when we're trying to figure out how spread most of the data is we're trying to get a good idea of how spread most of the data is. And most of the data is up here. So when there is an outlier, we don't, I X'd the wrong thing. When there is an outlier, we don't use the standard deviation because the standard deviation is greatly affected by that outlier. And we want to know the spread or the variation of most of our data. So what do we use? So recall a minute ago where we found our median. Our median is right in the middle. And recall from previous lessons that we've learned what the Q1 is. Remember that the Q1 is the middle of the lower half of the data. So in this case, it's 89.5. And the Q3 of the data, since I have the same number on either side, the number in between is 97. And remember that we use IQR, interquartile range, that is also a measure of spread. So we'll take our Q3 minus our Q1, and we find that that measure of spread is 7.5. And 7.5 represents how spread out most of your data is if you don't include the outlier. And that gives us a better idea of how spread out most of the data is because the IQR is still going to be represented by these middle values. So it doesn't get changed as much by an outlier. So what's the big idea we should get from this? If you have a set of data where there are no outliers, so these are all very close together, in that case, the mean is a good measure of center, and the standard deviation is a good measure of variability or spread. But when you have an outlier, as we do here, the median is the best measure of center, and the IRQ is the best measure of variability or spread. And the reason for that is the mean and standard deviation are skewed. Remember, skewed means they can be dragged down or they can be dragged up. So they are more affected by outliers. But the median and the IRQ, are not. So the mean and the standard deviation are very much more affected by outliers.